Okay, welcome to another marathon video for algebra. This is again an O-level video, and this is paper 2, which means that you're allowed to use a calculator. Let's start solving the questions. This is a continuation from the previous video, of course. This is remove the brackets and simplify. I think that's pretty simple. You multiply q with 2q minus r, and similarly you multiply 3r with 2q minus r. Okay, and you get 2q squared minus qr plus 6qr minus 3r squared. Do I see something added and then subtracted? Yes, I see something being added, subtracted. So 5qr minus 3r squared. And that should be my final answer. It says given in part B, it says given that m equals to minus 2 and n equals to 4, evaluate 5m cubed. So 5m cubed. So I can put that on my calculator. I don't need to do that manually, and I get minus 40. Part 2 says m over n plus n over m. So again, I'm going to write minus 2 over 4 plus 4 over minus 2. Again, this is something the calculator can manage on its own. I hope everybody knows how. So that is my calculator. I can then go on and write this on my calculator. I can write minus 2 over 4 plus 4 over minus 2. That gives me minus 5 over 2, and that is my final answer. If I want to write that as a mixed number, I can also do that. If I press this, it gives me a mixed number. So that's your call what you want to write. But she says factorize completely. The first thing when you do when you're factorizing is you look for a common. So I've looked for a common, and then I see two terms, both of which are squared. So I'm going to say that this is the difference of squares, which can be factorized to y minus 1 into y plus 1. When you have two terms, that is what happens. Part D, Peter has 200 and Paul has 2120. When they are each given rupees X, Paul has 5 times as much as Peter. So Paul has 5 times as much as Peter. That is what I'm going to write as my equation. They had both 200 and 2120 initially, and they're both given x. So I'm going to write 2120 plus x. And what does Peter have? Peter has 200 plus x. Okay, that gives me 2120 plus x equals to 1000 plus 5x. So 2120 minus 1000 equals to 5x minus x, which is 4x. So I have 1120 here. Now I can use my calculator and get to my final answer. I get 1120 divided by 4. I get 280 equals to x. So each of them was given 280 rupees. Okay, moving on to the next question. These are 4 terms, so this is a question on factorizing by pairing. That's what we've learned. So in the first 2 terms, what do you see common? You see t common, so I'm going to write 2v plus 1. In the next 2 terms, I see something in 5 common, but I'm going to also take a minus common so that the brackets match. So I'm going to say minus 5, so that gives me 2v plus 1. These brackets are then matching, so I'm going to write the bracket. What is left over from the first term, it's t. What's left over from the second term, it's minus 5. So I have my 2 brackets, t minus 5 and 2v plus 1. Make k the subject of the formula. So first I'm going to have to remove the root. That's what I'm going to do. I remove the root. So h over k equals to 9. And then I want to make k the subject, so I'm going to say that this is h over 9 equals to k. But she says solve the equation giving both answers correct to 2 decimal places. Whenever this is the case, this is then a question that has to be solved using the quadratic formula. So a is 1, b is minus 23, and c is 81. So My quadratic formula is minus b plus minus root of b square minus 4ac over 2a. I'm going to write minus 23 plus minus 23 squared minus 4 times 1 times 81 over 2 times 1. Okay, putting this on a calculator, I'm going to first write it with a plus and give you one answer, and then write it with a minus and give you the other answer. Um, let's do that. So two decimal places. So the first answer that I'm getting is 18.66. So x equals to 18.66. That's from the one with the plus, and the other one with the minus is 4.34. And those answers are matching, so those are the correct answers. Okay, then it says remove the brackets and simplify in the next question. I think that's simple. 4 into 3 is 12 minus 8p minus 3 plus 3p. So that gives me 9 minus 5p. The second one is also simple. I can first multiply 3q with q plus 2r and then minus r with q plus 2r. 3q squared plus 6qr minus qr minus 2r squared. And this looks very similar to the previous question. And it just factorize completely. So I see what common do I have. I see common as 2, so 90 square minus 1. Then again I see a difference of squares. So this is the square of 3t, which is 90 square, and that's the square of 1, which is 1. So can I break it down and write it as 3t minus 1 and 3t plus 1. Then part C looks simple. It says y equals to 18 plus 3x squared. Find the value of y when x equals to minus 2. So this is just a calculator application question. Let's put that on a calculator and see if we get the right answer. I get 30. It's part 1. Part 2, find the values of x when y equals to 93. That's 93 minus 18. That gives me 75. Then I get 75 divided by 3. You get 25. In order to remove the root, you remove the square, you take a root on both sides. That leads to a plus minus. So my answer is plus 5 or minus 5. Both will give me the correct answer. Then part 3, it says express x in terms of y. I have to make x the subject. So y minus 18 equals to 3x squared. And x squared is y minus 18 over 3. Now again, to remove a root, to remove a square, you put a root and you write x equals to plus minus root of y minus 18 over 3. Question 4 says it is given that y equals to 3x squared minus 12 over 5. Find y when x equals to minus 3. So part A, 3 times minus 3 times 0 times 5, 27 minus 12 over 5. Essentially, I can do this on a calculator. I don't need to do this manually. But I do get 3, so that's fine. Okay, then part B. Part B says find the values of x when y equals to 0. First, you cross multiply the 5. 5 into 0 gives you 0. Then you take 12 to the other side and say that this becomes 12 over 3. And then you put a root. Okay, 12 over 3 is 4, so x equals to plus minus root of 4, which is equals to plus minus 2. Okay, then it says for the values of x in the range minus 3 to 2, write down the largest value of y. Okay, now in order to find the largest value of y, what I will have to do is I'll have to do a bit of trial and error from my calculator and see that at what point does y become the largest. I know that y at this end point that I had, it was at 3. Okay, what I will do is I also want to find the smallest value of y, so I'm going to try out all the values and say that when x was minus 3, y came out as 3. When x was, let's say, minus 2, I can say that y should be 0 because that's what I just found out. What about x equals to minus 1? Let's do that. Okay, so 3 times 1 minus 12 divided by 5. That gives me minus 1.8. What about x equals to 0? And then x equals to 1. And then x equals to 2. All these values have to be found. And that gives me minus 12 divided by 5. That gives me minus 2.4. That again should give me 1.8. And that should again give me 0. Okay, so I have the largest value of y, and that is 3. What is the smallest value of y? That is minus 2.4. As you go on and study more, you will do a chapter called quadratics where you can find this directly as well. But since this is an algebra question in a earlier worksheet, I am doing this with a bit of trial and error. D. Express x in terms of y. If I cross multiply 5y, then I bring 12 to this side and I divide by 3. Take a root in both sides, and that gives me my required answer. Part E. It is also given that y equals to t minus 3 over 2 when x equals to t. Okay, show that t satisfies the equation 6t square minus 5t minus 9. So what I'm going to do is first I'm going to write my earlier expression, and this is the new expression. So it says when x equals to t, so that means 3t squared minus 12 over 5. So now since both of these are y, they can be equated, and I can say that when you cross multiply 2 to this side and 5 to the other side, and let's see if we get what we wanted. Okay, yeah, we have the equation that we wanted. Then it says solve the equation giving your answer correct to two significant figures. Giving your answer correct to two significant figures. So I'm going to again say that this is on quadratic formula. I'm going to use my quadratic formula minus b plus minus root of b square minus 4ac over 2a. And I'm going to put that on my calculator and work it out. And two significant figures gives me t equals to 1.7 and t equals to minus 0.88. Let's check if those are the correct answers. Yes, those are the correct answers. Moving on to question number 5, it says express as a single fraction. So the first thing that I'm going to do is take it to common denominator and say that the common denominator is x plus 3 into 2x minus 1. This has to get multiplied with 2x minus 1 and this has to get multiplied with x plus 3. So I get 4 into 2x minus 1 minus 3 into x plus 3. That gives me 8x minus 4 minus 3x minus 9 over x plus 3 into 2x minus 1. I get 5x minus 13 over x plus 3 into 2x minus 1. Part B. Express m in terms of k, l, and n. Okay, so I have to make m the subject. First, I'm going to remove the root by squaring both sides and say that this is k squared equals to 2lm plus 3n. Then I can move 3n to the other side because I need to express m. So m is equals to 2k squared minus 3n divided by 2l. And part C is again a simple question on quadratics. So I'm going to pull out A, B, and C and say that this is minus B plus minus root of B square minus 4AC over 2A. Let's see if we get the correct answers out of this. I'm going to again put this on my calculator. 3 minus 4 and minus 6. Correct to two decimal places. So I'm going to say that x is equals to 3.07 and x is equals to minus 1.74. Okay, moving to the next question. It is expressed as a single fraction in its simplest form. Now, note that when you take a common denominator, you have to take the repeated factors only once. So I can't write 2x into 5x. That would be wrong because x is being repeated in both as a factor in both the expressions. So my expression is just going to be a combined 10x. 10x also has 2x in it and it also has 5x in it. So it's the lowest common multiple of 2x and 5x as well. Now, this is missing what? This is missing a 5 in the denominator. It's not missing a 5x. So this gets multiplied with 5 and that gets multiplied with 2. So I get 5 minus 4, 1 over 10x. 2. Now, notice that this is again, no, this is not just x minus 3. It should be x into x minus 3. We talk about factors. We've studied factors in the earlier lectures, and addition and subtraction doesn't lead to a factor. So it's being multiplied together. So what is this being multiplied with? X minus 3, and this will get multiplied with 7x because it's missing an x in the denominator. So I get 4 into x minus 3 plus 7x. In these cases where you don't have a common factor in the two expressions, you can just, sort of multiply it like that and multiply it like that. A lot of you must have learned it that way. It's fine if you remember it that way. So what do I get? I get 4x minus 12 plus 7x. 11x minus 12 equals to x into x minus 3. Yeah, those are the correct answers. Let's move on to question 7. It says express as a single fraction in its simplest form. Again, notice. Now, do you notice the factors? One is with a whole square and one is not with a whole square. So what you're going to simply do is you're going to write it once only. Why? Because this denominator already has x minus 4 in it. So this was a complete denominator, it just needs to get multiplied with 1. So I get x. This one is going to get multiplied with x minus 4. Why? Because it's missing an x minus 4 in the denominator. So that is what happens. So I get 8 minus x. Part B is simultaneous equations. I hope you've completed simultaneous equations as well. Let's quickly look at these. If you haven't, then please complete the lecture first and then go back and look at these videos. I have a feeling that I could eliminate the x in these expressions. I see a common factor 2x and 6x, so I could multiply this entire thing with 3 and get make it 6x. So I'm going to do that. I could also pick up 2 and 6 and make it 12x and 12x and both. It wouldn't matter. I'm getting this multiplied with 3, so I get 6x minus 9y equals to 42. 6x plus 4y equals to 3. I do a subtraction. Y equals to 39 divided by minus 13, which is minus 3. Then I use any one of the equations above. This is 2x equals to 5 and x equals to 5 over 2. Part C. X into x minus 4 plus equals to 6 plus x. So x squared minus 4x equals to 6 plus x. I have a feeling this is going to turn into a quadratic equation. 6 plus x. So I get x squared minus 5x minus 6. I can either factorize this or put it into a quadratic formula and solve it. Both are going to give me the same answer. I see that this is a simple factorization because minus 6 has simple factors 1 into 6 and 2 into 3. I need to pick up two factors in such a way that when added subtracted I get minus 5 and when multiplied I get minus 6. I'm going to say that I'm going to pick up minus 6 and plus 1x minus 6. What's common in the first two? X minus 6 plus 1 and x minus 6. If you find this challenging, just use the quadratic formula in paper 2. That is going to be the easiest way out. Okay, then either this equals to 0 or that equals to 0. So you have 6 and minus 1. Then simplification is easy. You just have to factorize and see what cancels out in the numerator and in the denominator. Remember that until you've taken out something common, you cannot cancel y's and numbers and so on. So this is the difference of squares. I see the square of y, I see the square of 9, square of 3. So I'm going to say, oh, this becomes y minus 3 into y plus 3. Then in the denominator, what I see is the quadratic expression. So I'll have to make factors of minus 30 and see what I get. 1 into 30, 2 into 15, 3 into 10, 5 into 6, and then 6 into 5 repeats itself. Have I found my factor? Yes, I found my factor. I need a number such that it gives me minus 1 when subtracted. So I'm going to write 2y squared minus 6y plus 5y minus 15. So I get y minus 3 into y plus 3. What's common in the first two? It's 2y, so y minus 3. What's common in the other two? It's 5, so y minus 3. The brackets are matching, and that also tells me that something from the numerator is helping me cancel that out. Y minus 3 and 2y plus 5. So I get y plus 3 over 2y plus 5. Okay, that completes this question. It was a long question. It was 11 marks, which means that we have about 15 to 20 minutes to solve this one. Okay, question number 8, it says solve the equation this. What I could do is I see a completed square form. It's a completed square form. So what I could do is either I could expand and convert it into a normal quadratic equation, or what I can also do is that I can um, immediately try to remove the square. And how can I do that? By taking a root. So this becomes x minus 5 and this becomes plus minus 9. There are two possibilities then. X minus 5 equals to 9 and x minus 5 equals to minus 9. What do I get? X equals to 14 and x equals to minus 9 plus 5 is minus 4. So those are the two answers that I'm getting. And part B says express as a single fraction in its simplest form. So I'm going to first take a common denominator and say that this becomes 2a minus 1 into a plus 1. Uh, okay, there was nothing common in the denominator. So this gets multiplied with a plus 1 because it was missing an a plus 1 in the denominator. And this gets multiplied with 2a minus 1 because that is what it was missing in the denominator. So I get a square plus a minus 4a plus 2. Okay, so I get a square minus 3a plus 2 over 2a minus 1 and a plus 1. Now I could factorize this further, and that is what the answer is asking me to do. So because it says in its simplest form, so this is not simplest form, maybe I could factorize this. I see factors of 2 can be made, so I'm going to make a square minus 2a minus a plus 2. And I'm going to say that the first two have a common, so I get a minus 2. The other two have minus 1 common, so I get a minus 2 again, and I get 2a minus 1 and a plus 1. So a minus 1 into a minus 2 becomes the numerator, and the denominator becomes this. And part C says I want to make a the subject. I'm going to make a the subject, m the subject, sorry, m the subject, m in terms of h and a. I'm going to first move this h and say that this is 4m plus h. And then I'm going to move that h and say that a over h minus a. And then 4 is going to get divided with both of these. It's going to become a over 4h minus h over 4. Quickly moving on to question number 9. It says it is given that s equals to n a plus l over 2. Find the value of s when n equals to 20, a equals to minus 5 and 17 over 2. So that I think gives me 120 on a calculator. That's part 1. Part 2 says express L in terms of S, N, and A. So I'm going to make L the subject. So I'm going to first multiply, cross multiply 2. So 2S over N equals to A plus L. Part B. Okay, that was, I think simplifying that was simple. Yes, the answers are different from there because I've not taken a common denominator, and that's absolutely fine. You can do that on the exam too. Okay, then part B says 5t square minus t square equals to 12t. Now remember that a lot of you have this habit that you take this t to the other side and cancel it out. What that leads to is a loss of the root. What you need to do is you need to bring this to this side and then say that a t can be pulled out common. So I get 5t minus 12 equals to 0. So either t equals to 0 or 5t minus 12 equals to 0, 5t equals to 12, and t equals to 12 divided by 5. That's part 1. Part 2. I think that's the easy way to simplify is to cross multiply this. So I get y minus 1 into y minus 1 equals to 2 times 8. So I get y squared minus y. Okay, since some people are really confused, that's what I'm doing. So y square minus y plus 1. So I get y square minus 2y minus 15. I'm going to use the quadratic formula. I'm going to say that a is 1, b is minus 2, and c is minus 15. And then I'm going to say minus b plus minus root of b square minus 4ac, just to show you that this is at times quicker rather than thinking about factors, although I could have thought about factors as well, but this works. I mean, just use my calculator now rather than trying to show you calculations. I'm going to do that. 1, so y is 5, y is minus 3. Those are the two numbers that I have from my calculator. Then it says solve the equation giving both answers correct to two decimal places. So again, this is about the quadratic formula again. I'm going to write ABC again and then try to solve it for you. Okay, one is with the plus, the other one is with the minus. So you do that and you put it on your calculator and you get your final answers. Is two decimal places. So minus 0.74 and minus 2.26. Question number 10 looks simple. Let's quickly solve that. First, I cross multiply this. I get 3t plus 1 equals to 8. 3t equals to 8 minus 1. T equals to 7 over 3. Part A. Part B is simultaneous equations. If you look closely, they've sort of misled you by giving you this in an alternate, a switched form. So this is actually cancelling out. Okay, so 68 divided by 4 gives me 17, and I can then quickly find out x. Part C is simplify, so I'll have to simplify both the numerator and the denominator. I'm going to make factors for 12 in this case. So what are the factors of 12 that I can think of? That will give me 8, 2 into 6 obviously, so I'm going to say that it's simple. Again, 3y squared plus 6y plus 2y plus 4, and the denominator has 2 squares, so it becomes y minus 2 into y plus 2. Then in the numerator I have 3y common, and then I have 2 common, so I get y minus 2 and y plus 2. So in the numerator, the bracket that's common is y plus 2 and the other is 3y plus 2. And in the denominator, I have y minus 2 and y plus 2. So I think these cancel out and I'm left with 3y plus 2 over y minus 2. But D then goes on and says express x in terms of. So I think I'm just going to gather the x terms on one side. 2x plus gx, 2f minus 3h. I factor out an x. So 2 plus g equals to 2f minus 3h over x. Oh, my bad. I had to move the 2 plus g to the other side. So 2f minus 3h over 2 plus g. Yeah, that's correct. It brings us to the end of question 10. Let's quickly see question 11. It says factorize completely. So that's what I'm going to do. I'm going to first pull out the common and then say that this can be further broken down into x minus 2 into x plus 2. Now I see that in the numerator. I also see something in the denominator. That's a 10 common in the denominator. Why? Because otherwise the numbers will be very large. So I'm going to just factor out this 10 and then say that the factors then inside are very easy. I just have to break up 2. So I'm going to say that this inside the bracket can be broken up into 2x minus x minus 2. What are the common factors? Minus 1x plus 2. Okay, so then I have 10. One of the brackets is x plus 2, the other bracket is x minus 1. Remember that this 10 is just multiplied with the two brackets together. It's not multiplied with each individually. So you can just write it once and then that's pretty much it. I see something, a lot of things cancelling out. Let's cancel them out. 5 times 1, 5 times 2. So I get my final answer is x minus 2 over 2 into bracket x minus 1. Okay. Then part B says express as a single fraction. Uh, it, I think expressing as a single fraction is simple. The common denominator doesn't. None of the bases, none of the fractions have the denominator have anything in common. I'm just going to multiply. So 4y plus 20 minus 3y plus 9. So I get y plus 29 over y minus 3 and y plus 5. But see, g in terms of, so I have to make g the subject, so I'm just going to bring 2 pi to the other side first and leave the root L over g here. Then I remove the root by taking a square on both sides. So that gives me t square over 2 square into pi squared equals to L over g. So I can bring g to this side and take a reciprocal to bring all of these on the other side. 4 into pi squared. So this becomes 4 pi squared L over t squared equals to g. So I've switched the places. I've brought g up here and moved this down there and moved this up here. Okay, the last question on this. Let's try to solve this. This has a word problem in it as well. Let's first cross multiply and try to solve this. I can't cross multiply right now because I see two fractions right now. It is going to become tedious unless I take common denominator first. What I'm going to do is I'm going to say that this is 2p plus 1 over 3. This is 1 over 1, so I can take common denominator 2 and this becomes 2 plus p minus 3. Now I can cross multiply. I can say that this gets multiplied here, so that gives me 4p plus 2 and this gives me 3 into 2 6 plus 3p minus 9. It's obviously getting added and subtracted, so you do that and 4p minus 3, 6 minus 9 minus 2, 4p minus 3p p. That gives me minus 5 at the end. And yes, that's the correct answer. That was part A. Part B says again simplify. There is something common in the numerator. Okay, although it's not a difference of squares like the previous parts. And this 3 has to be broken up to get minus 2v, so I'm going to say minus 3v plus v minus 3. So in the numerator I have 2v minus 3, v, v minus 3 plus 1 v minus 3, 2 v minus 3, v minus 3 into v plus 1. Cancels out. I'm left with 2 over v plus 1. Okay. Then part C looks challenging. Let's look at that. It says the tens digit of a number is x and the units digit is y. Hence the value of the number is 10x plus y. Okay, that makes sense. For example, if x is 5 and y equals to 56, y equals to 6, so we're talking about the number 56, which is 10 into 5 plus 6. When the digits x and y are reversed, the value of the number is increased by 63. Okay, so show that y minus x equals to 7. Okay, let's try to do this. So when the digits are reversed, so that would mean 10y plus x. Okay, so that's the new number. What is the old number? The old number was 10x plus y. The difference between them is 63. That is why I put a subtraction sign in the middle. So 10y plus x minus 10x minus y equals to 63. So that gives me 9y minus 9x equals to 63. What do I see common? I see a 9 common, so that's 63. Y minus x equals to 63 divided by 9. Y minus x equals to 7. Then it says the sum of the original number and the number with the reverse digits is 99. Show that this, okay, that also sounds simple. I just need to take the new number, which is 10y plus x, and sum it with the old number. I think it's 99. So that gives me 11y plus 11x equals to 99. And that gives me 11 common. So y plus x equals to 9. Okay. Hence find the value of x and y. So I have a pair of simultaneous equations. That's what the third part is asking me to do. Y minus x equals to 7 and y plus x equals to 9. 2y equals to 16, y equals to 8. 8 plus x equals to 9, x equals to 1. Yes, those are the correct answers. That brings me to the end of this worksheet. I hope this was productive. Please make sure to like, subscribe, and comment in the comment if you have any questions. I will see you with another video on algebra word problems very soon. Thank you for watching.